Thanks, Sean. So Greg and I are going to present, and because we have a lot to say, we're going to go probably too fast. But Greg is an internal medicine doc doing his fellowship at UBC, and we met after a talk that he gave, and I had talked to him about coming to Kenya to do a rotation or two, and he called me up the next week and said he was going to come for the year. So it was a pleasant surprise, and he's going to be showing some of the work that he's been doing with us on OpenMRS. So we're going to try and accomplish quite a few things today. So I have no disclosures. I'm going to talk to you about kind of how we got to where we were with OpenMRS in a very brief way, and then where AMPATH started taking a different course. I'm going to talk briefly about a new way that we are thinking about how to collaborate on the building and development of OpenMRS. And then Greg is going to present on a vision that he has, and he's been working with others to develop on what an EMR could and will look like for OpenMRS. I am an AMPATHer. I've been working at AMPATH since 2013. For those who don't know, I know it's mentioned a lot, but AMPATH is a collaboration between Moi University, Moi Teaching Referral Hospital, and then quite a few North American institutions with a mantra that care leads the way, but it is a combination of care, education, and research. And many different institutions are involved in a collaborative way, which is somewhat unique in the global health setting, where oftentimes we're all competing for the same grant. Answer. I suppose that may be true domestically as well. So I am going to skip to a brief history of OpenMRS. So in the pre-PEPFAR days, AMPATH was taking care of small numbers of HIV patients through philanthropic funds. There is a huge story to be told about the care side of this, but that will not be my focus today. And you can see visualized there Bob Eintertz and Joe Mamlin, who are here today. They probably don't appreciate me saying that. They like to keep low profiles, but they have done great and amazing things. And then Sylvester Camayo is in the bottom right of the picture on the right, and he is the current chief of party of AMPATH and a force in how we have moved our program forward over the years. So in the beginning, we knew we wanted to collect data. We had a few goals, something that was relatively easy to use and cheap, and we used we created the Masoriot medical record system, and Bill Tierney, I wanted to honor him there, was one of the leaders behind kind of this movement as it expanded. Now this was an access-based system, and it worked for the few hundreds of patients that were being cared for by AMPATH early on, but AMPATH expanded once PEPFAR was created. PEPFAR, for those who don't know, is the President's Emergency Plan for AIDS Relief, and it essentially provided billions of dollars to provide HIV care in sub-Saharan Africa and other places. So we expanded rapidly from a few hundred, maybe 1,000 patients to tens of thousands of patients. And this kind of just gives you an overview of our territory in Kenya. Hundreds of kilometers of distance. In the old days, there was not a lot of tarmacked roads, so getting back and forth between them was not so easy. And we had a great need to collect data. And so this eventually happened, although technically this is from Excel, but just imagine that it's access, that the Microsoft product became overloaded and couldn't support the continued efforts for data collection that we needed. So enter OpenMRS. This is now around 2004, 2005. With Paul and Burke leading the way on this project, along with others at Partners in Health, and certainly getting a lot of support from Regenstrief to make this dream a reality. In the beginning, this is where OpenMRS was, Haiti and in Kenya, and this is where it is now. So a remarkably successful and impactful project over time. Now, AMPATH initially set up OpenMRS in our data center with a retrospective data entry process. So here's a quick shot of kind of the data center that we have in AMPATH. So we don't use cloud. We just maintain our own rack servers at the hospital, at Moy Teaching Referral Hospital. And you can imagine we have tens of thousands of encounters being written on paper, being collected in folders like this. So this is a kind of example of the paper version of the chart of the paper, what was being filled out on a daily basis for patients, and then that's the electronic version. And this team would fill them out, and these things would be brought in from all over the place. And as I think I've mentioned before, you kind of had to be UPS to figure out how to get them from clinic to data entry facility back to clinic in a time that was reasonable, so that the provider could actually see the patient before the form, so the form came back before the provider saw the patient again. And this was successful. So, I know the numbers are small, but it goes up to 700,000 on the y-axis, and it's years on the x-axis, and this is through 2015. So by 2015, we're doing something like 400,000 encounters a year, and all retrospectively entered. Okay, so you can imagine that with that much paper, you start to have something that looks like this, and then eventually you get to something that looks like this. Actually, this was old storage, but I think it proves the point. And we're asking our clinicians to manage tons and tons of paperwork, and to, as the amount of time that people are living with HIV extends, their charts grow much, much longer, and it's harder to really figure out what's going on with the patient over time. And this led to some challenges for us. So in 2015, we were somewhat at a breaking point. There was a feeling that the quality of the data just wasn't there because the people who were collecting it never got to use it. There was significant delays in data entry, and in general, this led to a host of issues related to data quality. So this is when I became involved with the project. This essentially created an opportunity and a job for myself. So I came on to lead the informatics program in 2015, and the goal at that point in time was to move to a point of care system. And I had the good fortune to be able to build kind of all the teams necessary to develop, test, implement, and maintain the EMR. And here is a quick picture of our team. And this is a more recent picture. Now, what were we building exactly? So for those of you who are not familiar with OpenMRS, it does come with the UI, but we didn't feel that it met our needs because we were primarily going to be using this on mobile devices with 8-inch screens, and the way that the user interface worked really didn't support kind of that type of device very well. It was a very difficult user experience. So that A, for those of you who are not familiar with JavaScript frameworks, stands for Angular. It's a framework that is maintained by Google. There are many competing frameworks. We chose this one at the time. It's a single web application. That means that when you go from different places in the EMR, you don't move from page to page. You kind of stay where you are. The page is not refreshing. We believed at the time, and this wasn't really a unique insight of ours, that JavaScript was the future for front-end development. And at the time, OpenMRS was not really using JavaScript to develop. And we wanted to have all of our developers working on a single language rather than spreading them across. We really didn't know kind of how successful this project was going to become, or if it would work at all. We knew at the time we were diverging from the standard that OpenMRS was using, but we felt it was important enough to AMPATH that we took this risk. This is a very quick snapshot of some of the pages that our application has. I'm not going to focus a whole lot on what it looks like now, but just to show you that this is our EMR. This is AMPATH's EMR that we call AMRS POC, or just POC for short. And here's another page. And then here are some people who are using it. This is in the lab at MTRH. You can see that he's using it on I think it's a 10-inch Chromebook. And there's a little label printer that he uses, that this is the lab tech uses to print out the stickers for the samples he's collecting for viral loads. So I'm going to bring you to this slide here, and this shows you encounter entries by type. So I'm just going to focus on the left and the right. Basically, what you see on the left is the purple and the blue are forms that were entered retrospectively. And then you can start to see the shift happening in 2015, where we start entering most of the forms through the point of care. So this is a humongous shift in terms of how you implement an EMR. And the consequences are that now, instead of having 10 people who are using the EMR to enter data, we end up with 500 different users at any given time during the day. There's 200 users using the system who have technical support issues and need guidance and training on how to use the system. Importantly, as was always the dream for OpenMRS, it wasn't supposed to just be for HIV. And so as our success in the HIV program grew, we were able to start integrating other clinical care programs onto the EMR. So this shows you from January 1st to present. The x-axis is the max is about 100,000 encounters, I think. I know it's a little hard to see, but it's showing you that now we do this for chronic disease management, for oncology, and we are starting to expand into further programs. So truly a lot of success in terms of integration. Now, the problem is we're victims of our own success. We're now maintaining an entire EMR, or at least the front end aspect of an entire EMR, using a very small team and rebuilding a lot of the same stuff that every other implementation of OpenMRS is doing. And we can't continue to expand services to support the whole care system using just our small team. Now, one problem with collaboration is that OpenMRS is still primarily using a very old technology called JavaScript pages or Java server pages. It's a server, and I'm not going to get into the details of the technical side of this, but suffice it to say it's time for OpenMRS as a community to shift. In the meantime, because OpenMRS as a community hasn't really shifted, we have many implementers making their own versions, just like AMPATH has been doing. And because we've all done it slightly differently, we can't collaborate very well together. So we're moving to, I wouldn't say this is a new vision at all, but we are re-emphasizing it, that our goal is to build a comprehensive EMR that data can be used to support the entire health system, not just verticals, and not just and one that really allows collaboration across the entire OpenMRS community. Two goals. First is to make it modular, and that means to figure out some way to allow all of us to collaborate on the front end in ways that doesn't break our EMR distributions, and to add FHIR, so make it hot. I'm going to talk very briefly about microfrontends. Some of you may have heard of microservices. Microfrontends is kind of the next iteration of this, where you have each component of the web application divided up into fairly protected and sandboxed applications that can be upgraded and worked on without causing damage to the rest of the application. I'm going to go quickly, but this is a huge deal because it is the way for us to collaborate on the front end and to divide up an EMR and to really kind of convert something into like a smart on FHIR approach, some way of bringing everything together without affecting the whole rest of the system, and provides enough independence to the developing team for what they want to build. Now, some of the benefits, without going into too many technical details, there's Angular, there's React, there's Vue, there's all these different ways of doing stuff that people have opinions about and they don't want to change. With this approach, you can use what you want to use. So it brings in everybody into the tent and allows us all to work together. In general, this creates a much better user experience. You're not moving around from different places in the application, and so everything stays somewhat consistent. And as I said, there's independent development and deployment. This is what our EMR looks like now. And we are a single web page application, so it's a giant monolith, meaning everything is kind of packaged in one source, one amount of code. Microfrontends, this is taken from microfrontends.org, divides everything up so that each little thing on the page becomes its own application. And I'm going quickly because I know I'm running late on time. But you can imagine taking that same EMR page and dividing everything up into different components that are completely independent of each other and allowing all these teams to work together in a very facile way. We are going to use something called single spot to glue everything together. And it turns out I emailed this guy who is one of the foremost experts on micro front ends just to see if we should use his framework. And lo and behold, he was looking for an opportunity to contribute to an open source project. And he's on his way to Kenya in a few weeks to collaborate with us. So this is just beginning. This is the OpenMRS request for comment repo. I encourage any of you who are interested on the tech side to take a look at this. This is actually really just discussion right now. There's no code. But this is a very exciting thing that's going on right now, and we're just really at the beginning. Now going back to FHIR. FHIR is coming, but not right now. Okay, just smoldering. It's the next project for us. So coming back to the vision, yes, to create a world-class open source EMR, but let's make it awesome. Let's make it beautiful. Let's make it work for users, and let's make it really something that is just as good as Epic or Cerner or any of the other commercial systems. And let's show them that we can do it here at Regenstrief. And with that, I'm going to turn it over to Greg to go into the next bit of the talk. Thanks.
All right, thank you very much. I'd like to spend the talk talking about two things. First, I'd like to talk about the challenges that we're trying to solve when we're building health informatics tools. And then the second part is I want to become very practical and actually show you some examples of tools using this modular building block front-end user interface to solve those challenges. And the whole reason that we're talking about this is because groups such as AMPATH, Partners in Health, and many ministries of health from around the world are trying to deploy new healthcare systems. And they need tools that are more powerful and more flexible than the current point of care systems and tools that they currently have. And so what we want to talk about is the critical need to do continued research and development in fundamental electronic medical records. And of course, the Regenstrief Institute is the obvious place to lead that type of effort on a global level. And so when we think about design, what is design? Well, most people make the mistake of thinking that design is what it looks like. People think it's the veneer, that designers are handed a box and told, make it look good. That's not what we think design is. It's not just what it looks like and feels like. Design is how it works. This is, of course, a quotation from Steve Jobs, and it underscores the critical point that design is actually how something works. And so if you want to evaluate if something is a good design or a bad design, you need to understand what is the purpose of the tool that you're trying to design for. And so when we think about building tools for global health informatics, the question is, what are the challenges in global health that we're trying to build these tools for? And there are no shortage of challenges in global health. We know that in developed countries, the current care systems are in the long term financially unstable. We know it takes over 10 years to train a physician, that the growth of the body of medical literature is growing at a rate faster than clinicians can keep up with. And despite all of this, we also know, and I find this quite shocking, that healthcare is pretty much the only sector of the economy in the last 3 decades that has become less productive. And so despite all this energy and investment that we've been putting into healthcare, we're still left with a system that has very high variation in the quality of care. And whenever we say that there's high variation in the quality of care, it's kind of a euphemism for saying we make a lot of mistakes in healthcare. And so we don't want to take this system, which we have in Western countries, and scale it around the world. And in addition to the problems we've discussed with the system, which we currently have, we have on a global level a significant shortage of workforce. We have only a marginal ability to pay for healthcare in many countries. And the challenges of delivering care in many countries, given the remote locations and the limited human resources, pose even new challenges. And to compound all of these problems, when you look out over the next half a century and over the next century, on a global level for population, we see that those who need care the most in the globe will be groups such as those living in Asia, and of course, those living in Africa. And Africa in the next half a century is going to double in its population, and in the next century, it's going to triple in its population. And so building healthcare systems for the 5 billion and the future 10 billion who currently don't have care systems is not just a moral imperative. It's not for justice. It's not only bringing hope in the face of illness, but functioning healthcare systems are critical for global security because that will allow us to identify and to respond to the inevitable pandemic, which will come our way through things such as influenza or bioterrorism. And so we have a lot of challenges in global health, and we have a lot of good reasons to address these challenges. But the question is, do we have the tools to be able to address this? And one of the critical things when we think about addressing these challenges is this concept of task shifting. What task shifting does is it takes work which used to be exclusively done by a physician and makes it possible to do that work with non-physicians or with patients or with families. And most of the success of the AMPATH HIV care network is its ability to do task shifting at scale. And the way that they're able to do task shifting at scale is through the use of point-of-care medical record tools. Because that point-of-care medical record tool becomes the critical link between the patient, the provider, and the care system. And there's many advantages for point-of-care tools, but the critical one I want to talk about is clinical decision support. Clinical decision support not only elevates the quality of care delivered by all levels of healthcare practitioners, but clinical decision support allows us to take healthcare workers with reasonably entry-level training and elevate their skill set to be able to provide care at a higher level, because we offload some of the cognitive work of that care delivery to the digital tools. And of course, we know about the value of clinical decision support because people such as Clem MacDonald in his 1976 paper in New England Journal of Medicine. And we, of course, have a lot of buzz today about clinical decision support through advancements in things such as machine learning or artificial intelligence, which will allow us to build even more sophisticated clinical decision support, which allows us to do even more advanced task shifting, which allows us to build even more advanced types of care systems. And so those are kind of where we're going with this. But it's very important to realize that as we shift more work to a more large network of care providers, we actually need, this dramatically changes the flow of information in the health system. What ends up happening is in the old model of care, one provider might look at an electronic medical record and treat it almost as a digital vault, something you put information about the patient into and that you take information out of from the patient. But what we really need is the EHR to become a quarterback, to become the road network which coordinates care among the many providers. And I think from my perspective, the reason that so many people in the West are frustrated with their care being fragmented is because the medical record tools we have are still operating in the old model of care. We have care being delivered in multidisciplinary teams, but these tools aren't really designed to act as a quarterback and a road network to integrate care. So this is conceptually kind of what we need to go with these types of tools in order to build future healthcare systems. So let's look at a few concrete examples. In the case of AMPATH, we have many different users. We have community health volunteers that might take blood pressures. We have nurses that might be in a dispensary treating people with HIV or diabetes. We have oncologists in tertiary academic hospitals who are taking care of patients with breast cancer. And we have, of course, managers who are evaluating the system. And so how do you build a tool that you can use across all these different types of care providers, a tool that works across phones and tablets and desktops and laptops, and that adapts to all these workflows? Well, I think the answer is not to install Epic or Cerner or Allscripts or a large off-the-shelf EHR. It's not going to solve all these problems, all these unique workflows, and especially given the challenges in global health where computer literacy among our users is very low. And so these tools have to be incredibly user-friendly and incredibly easy to use. And so our principle that Jonathan's been talking about is we want to use modularity as an organizing principle in order to accelerate the ability to more easily build tools for global health. Modularity is used everywhere else in the world. It's how you assemble cells, atoms, construction, or manufacturing. Modularity is just the ability to have reusable self-contained components. And one of the critical values with modularity allows you to essentially take the medical record, which is this large entity with hundreds of functions, and take a pair of scissors to the medical record to cut it up into separate functional domains, into smaller blocks. Because now if you have smaller blocks, you can assemble the blocks that you require for the application that you're trying to solve. And it makes it easier to build new applications. And if the block isn't in that set of larger blocks, in that toolbox, you could just build the new block rather than having to start from scratch. And so what I would like to do is actually show you some examples of these block-like systems. And so if we were to start with the simplest application you could possibly come up with, you would just need two panels. You would need the ability to identify a patient, panel 1, and then once you find your patient, you need to put in some information, perhaps to complete a form. This would be the simplest informatics app you could possibly build. So if we wanted to build this application for a community health volunteer, for a outreach worker who's following up on patients who missed their HIV appointment, you need to pull in the list component into your application. And in this case, we have a list component. And so that's just the navigation part of the app. And then when you click on a patient, it's going to open up the workflow part of the application. And this workflow part of the application is designed to be able to pull in any Lego blocks that you need for that particular workflow. So what does this outreach worker require in order to follow up a patient who missed an appointment? Well, they're going to want to start a workflow. This is just a high-level stencil, but you're going to want a component which shows some demographics about the patient. You're going to want a component that shows a summary about that HIV care. You're going to want a panel that shows their list of prior appointments. You're going to want to be able to then phone the patient, to ask the patient some questions about their care, to write some notes, and then you're going to want to be able to book a follow-up, to go see the patient, or to book an appointment. Each of these entities is a self-contained block that you can pull in from this toolbox of all the EHR components. And our hope is that this toolbox would be robust enough that you could essentially assemble any application you require for this workflow manager. And of course, what you would also need is, in addition to the ability to have a workflow manager, you probably want to have a generic patient chart. And that's what we're calling the magic chart. And the reason it's a magic chart is because you can actually build one chart, one generic patient chart to view the clinical information, but you can filter the information in that chart based on the particular need. So in this case, we're filtering the chart for the HIV program for an outreach worker, meaning that the medications which are relevant to the HIV program are going to be in bold. They're going to be at the top of the list. When you look at the list of the patient's past medical encounters, all the encounters related to HIV and outreach workers will again be in bold at the top of the list. And so this way we can take one generic chart and make it specific while not losing context about the rest of the patient's care. And so it creates an incredible amount of flexibility. Now, of course, you could also, we're just short on time, but you could also do this on a tablet. Oh, I have extra time. Okay, I was going to end very shortly. All right. You could also do this on a tablet where you could have a split screen interface where perhaps the left side of the tablet is that generic patient chart. You can view labs, you can view medications, you can view past encounters. And then the right side of the application is that highly flexible workflow part where any organization can build all the workflows they require to do more data collection. And of course, you could make either side of this screen, you could make the patient chart in full screen, or you can make the workflow part of the application in full screen. It also makes sense that if you were on a desktop device, it'd be very easy to multitask. You could put the old patient chart on the left, and then you could have that workflow panel on the right, allowing you to enter patient information and view historical information. There's a lot of things which we still have to work out. For instance, what if a patient is coming in for a follow-up hypertension appointment, a follow-up diabetes appointment, and a first encounter HIV appointment? How do you take these three separate workflows, merge them into a custom workflow for that one patient during that one encounter, and then distribute the work among the particular people who are in clinic at that day? So if you have a nurse, a pharmacist, and a clinical officer. So you need to do dynamic task shifting based on custom patient workflows. And this is an area which I think we need actually quite a lot of R&D in, but is going to be really critical to being able to do task shifting at scale in global health. Well, that was the simplest application. And what we're working on now is this thing called the EHR User Interface Toolkit. This is just an early prototype, but essentially what the goal is to have all the components you would possibly need to be able to assemble any application. And it would have best practices for design of all these components. You could take components such as this medication summary panel, and you could just bring it into your application. So as an example, if you were building a cardiac clinic follow-up workflow, you could pull in the medication summary panel into your workflow. And you can see we've also pulled in a panel for vital signs, and we've pulled in a panel to ask some discrete data questions. You could do the same. We also want this. I've been talking to a lot of different groups who are very interested in collaborating on this. Essentially, it's an EHR user interface design community, because there's actually not a single place to go if you wanted to find all the best practices for user interface design in medical records. And you could share all the best research and development, the best mock-ups, the best examples, and the actual code for these components here. And if you build the components using FHIR resources, it makes them even more interoperable. Here's another example. You might, for instance, under immunizations, have several different components you could choose from to pull into your workflow to show a summary of the patient's immunization history. And you could pull a component such as this into the application. And now we're able to accelerate the ability for different organizations to build unique applications for their particular care needs without having to rewrite everything from scratch. And so this is what Jonathan was talking about when he was talking about the importance of modularity and making it easier to assemble applications. Well, that's the that's the design toolkit, and we're putting all of these ideas into a system called OpenMRS Flow, which is a project we're working with OpenMRS community on. And the project is to build an application that works on mobile, tablet, and desktop, something that works when you're connected to the internet or offline, when you're in a low connectivity environment and you don't have internet connection, that has this ability to create really flexible workflows very easily, and then also has that magic patient chart, the ability to essentially generate a custom chart for the patient based on the type of a clinic they're in. And we're bundling it in around this idea called OpenMRS Flow. And the goal is to be able to use it in parallel with your existing OpenMRS systems. So you could collect data using this type of a tool, as well as use your existing system, whether it's BOMNI, the reference application, the AMPATH medical record system, whichever it is. So that's kind of where we're going right here at AMPATH. There's a lot of research and development which is still required in these fundamental electronic medical record tools, because I feel in some ways that machine learning and artificial intelligence has taken the spotlight away from good old-fashioned electronic medical records. People view that artificial intelligence and machine learning as really the shiny thing. And I agree. in the long run, that is where we need to go. But the reality is that the system which is going to deliver the benefits of artificial intelligence and machine learning still comes down to good old-fashioned electronic medical records. That's going to be the road network which gets us into the hands of clinicians and allows us to build care delivery systems. And so Regenstrief is the obvious place to do this type of cutting-edge leading research, and a lot of that's going on with groups such as OpenMRS and AMPATH, and the work happening in Kenya. So if you're interested, of course, in helping, we would love to speak with you. Thank you.